All right, this is section 3.3, properties of logarithmic functions. We have several properties to go through, so let's dive right in. We're going to start with 3 rules of exponents. A to the m power times a to the n power. If the bases are the same, then we can add those exponents. A to the m power divided by a to the n power. Bases are the same, we can subtract those exponents, top minus bottom. A to the m power to the n power. We are going to multiply those exponents as so. Power to a power, we multiply. Division, we subtract. Multiplication, we add the exponents. I apologize, this is very blurry today. So we have 3 more properties of logarithms. B, R, and S are positive real numbers. B is not 1, and C is any number. We have the product rule. A log base B of R times S, we can split it apart into addition. Log base B of R plus log base B of S. The quotient rule, log base B of R divided by S, we can split it into subtraction. Log of the numerator minus log of the denominator. And the power rule, log base B of something to a power, we can bring that power down out front and have our logarithm from there. All right, we are going to now expand our expression using properties of logarithms. At this point in time, it's going to seem kind of pointless, but bear with me, there is a reason. So if I have division, that means I can separate it into subtraction. We take ln of the numerator minus ln of the denominator. We also have a power in here. Remember, a power can come down out front of that specific term. So natural log of y minus 2 natural log of x is fully expanded. For the next one, I have 5 times x to the 6th power in a log base 2. So I separate it into 2 log base 2's. First one 5 plus log base 2 of x to the 6th power. Then again, we have a power, so it can come down out front of that specific piece. So we have log base 2 of 5 plus 6 log base 2 of x. And there we have our expanded logarithm. Let's do some more. I see division. Let's deal with our division first. I take log base 2 of the numerator minus log base 2 of the denominator. Then in that numerator, I see some multiplication. Let's split that apart. Log base 2 of the 7 plus log base 2 of x cubed, still minus log base 2 of y. Oh look, x cubed. I can bring that power out front of my log. So I have log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And there's what we can do right now. Log base 5 of the square root of 8. Well, the square root of 8 isn't a number we know, but we do know that a square root can be rewritten as a power of 1/2. So I can bring that power down out front. 1/2 log base 5 of 8. And that's all we can do with it for now. And now log base 4 of the 4th root of x over y. Just like with order of operations, we want to deal with this whole root at once. Remember, a 4th root is the same thing as a 1/4 power, so I can bring a 1/4 out front. Then, try to refocus that a little. Okay. Now I see this division. Division splits apart into subtraction. But be careful, because the 1/4 needs to be on both parts. So it's 1/4 log base 4 of x minus 1/4 log base 4 of y. You could have also thought of this as, when you had the 4th root here at the beginning, you could have made it log base 4 of x to the 1/4 power over y to the 1/4 power, and then done the subtraction and then brought the 1/4 out front. All right, now we are going to condense. We are going to rewrite these as one single logarithm. So start with any powers. When I say powers, they're constants out front, move them up to a power. Log base 2 of x squared plus log base 2 of y. Then we're going to squish these together, and a plus becomes multiplication. Remember, it becomes multiplication inside of the logarithm, though. So we just have a single log base 2 of x squared times y. That's all we can do. There we go. Log of 6 plus 2 log of 2 minus log of 3. Remember, those have a base of 10. I see a power here, right? A constant out front becomes a power. So I have log of 6 plus log of 2 squared minus log of 3. Well, my addition can squish together to be multiplication inside. So we have log of 6 times 2 squared minus log of 3. Well, subtraction can combine to become division. So I have log of 6 times 2 squared over 3. Notice all of that is inside of the logarithm. This one's also funny because I can figure it out. 6 times 2 squared is 24 divided by 8. This is actually the log, divided by 3. This is actually the log of 8. All right, we are going to condense some more. So we start by saying, all right, powers. I have a 2 out front. I can bring it up, make it log base a of x squared. Same thing with this 3 minus log base a of n cubed. Since they have the same base, we can combine them into division. Notice I have 1 time log base a. We take the first thing, x squared, divided by the second, n cubed. And there's our answer. 5 ln of x minus 21 ln of xy. The 5 comes up to a power, ln of x to the 5th power. The 2 comes up to a power. I could write it like this, or I could have written that as ln of x squared y squared. Either way would be okay. Those are the same, all right? And then my subtraction becomes division. I have x to the 5th over xy squared. Now, one nice thing about distributing that square, so if I write it as x to the 5th power over x squared y squared instead, my x's can cancel. And actually, I have the natural log of x cubed over y squared in the simplest form. For this problem, if you said this top answer, I would not mark it wrong, probably though. All right, 2 log of all that minus 3 log of all that. To condense these, we take that power first. So I have log of x to the 4th y squared minus, move that power up, log of y z cubed. And then I'm going to turn it into division. So I have log of x to the 4th y squared over yz cubed. To fully simplify this, I'm going to keep going. So if your directions say fully simplify, you don't want to stop there. You want to combine things. X to the 4th squared is x to the 8th times y squared over y cubed z cubed. And then I see my y's can cancel, leaving me a y in the denominator. So I have the log of x to the 8th power y z cubed. Final answer. And then the change of base formula. So far, we could only evaluate logarithms that were ln or a base of 10. The change of base formula says as long as a and b are not 1, right, bases, log base b of x can be equal to the log base a of x over the log base a of b. A former coworker of mine, Mr. Budrow, always said, put the base in the basement. You can choose any base you want to use to switch it to, as long as you use the same in the top and the bottom. The thing inside the logarithm goes on top. The base goes in the basement. So let's look at how that could help us. I have the log base 3 of 16. Well, my calculator doesn't know how to do that. I can choose any base I want. I could say log base 7 for the top and the bottom. The 16 would go in the top. The base goes in the basement, so the 3 goes in the bottom. The But that doesn't help me at all. It just made my problem actually harder. But the reason this formula does help us is because there are two logarithms that your calculator knows. Your calculator knows the log base 10. So we could do the same thing, log base 10 of 16 over log base 10 of 3. Or we could use natural logs. We could do the natural log of 16 over the natural log of 3. And in case you don't believe that I could use either one, let's check it out. So log of 16 divided by log of 3. Make sure you close those parentheses, otherwise you won't get the right answer. We get 2.523719, blah, blah, blah. Now let's try with a natural log. Natural log of 16 divided by natural log of 3. Oh, look, we get the exact same answer. Doesn't matter which one you choose, pick one and go with it. I personally usually use log base 10. So our answer is 2.524. We're always going to go to the nearest thousandth place, that's 3 spots, and round it there. So let's try another one. Log base 1/2 of 2. We can choose any base we want. Let's use the common log of 2 over the common log of 1/2. Remember, base in the basement. So I take my calculator here. I have the log of 2 divided by the log of 0.5, because that's 1/2. I get -1. Well, wait a second, that checks out, because 1/2 to what power gives you 2? The negative first power, right? Okay. Log base 5 of the square root of 128. You have two options here. We could move that square root out front first, but we don't really need to. Let's use natural log this time. Natural log of the square root of 128 over the natural log of 5. Let's see what our answer is. Natural log of the square root of 128 divided by natural log of 5, 1.507. There we have it. So your assignment is out of the new textbook right here.